Hi everyone, in this lesson we look at relations, domain, and range. So first off, let's define what a relation is. And a relation is just a pattern or rule that associates each element in one set, which is the domain, with each element in another set, which is the range. Typically when we refer to the domain, we're referring to the set of the independent variables, which is the set of values on the x-axis. When we normally refer to the range in terms of a graph, we normally refer to the set of values, the set of y values, or the set of values on the dependent for the dependent variable. So you've already probably worked with a relation in previous math courses. One example of a simple relation would just be the equation of a line. Y is equal to 2x plus 1. Y is equal to 2x plus 1 is a relation because it relates values of x with values of y. And we can determine the domain and the range of y is equal to 2x plus 1. So another way of writing a relation is just by writing a set of ordered pairs, and that's what we have in this first example. So here it says determine the domain and range of the following relations. This is a relation, this set of ordered pairs is a relation because it relates each x value with a y value. So they're essentially coordinates, a set of coordinates. And these curly braces in math mean set of. So anytime you see curly braces in math, that means set of. So this just denotes the set of the ordered pairs 1, 2, 3, 4, and 2, 6. So if we want to determine the domain and the range, well, the domain is just the set of all of the independent values in this relation. So in this case, it's just the set of all the x values in these coordinates or these ordered pairs. So let's write out the domain is 1, 3, 2. Now there's a couple things in set notation that a couple rules that I'd like everyone to follow. One rule is that if you're listing numbers or letters or something like that, please list them in ascending order. So here we should list this as 1, 2, and 3. Another rule is that there's no repeats allowed when you're using set notation. So for instance, if I had the element 1, 2, 2, and 3, I would just list that as 1, 2, and 3. So no repeats using set notation. The range is just the set of y values, or the set of outputs of this relation. So we have 2, 4, and 6. So we'll write that the range is equal to the set of elements 2, 4, and 6. Okay, so next we have in example 2, instead of having a set of ordered pairs, we have a graph of some relation. It's actually the graph of a circle. So we're asked to write the domain and range of this relation. So notice that if all of my x values go between and include between -3 to +3. So I need all of the values, all of the real numbers between -3 and +3. So how do I denote that? Because I can't list out values like I did in example 1. So there's a special notation that we use for this, and it's called set builder notation. So the domain is the set, right? The domain is the set of real numbers, or the set of x in the real numbers, such that x has to be greater than or equal to -3, and x has to be less than or equal to 3. So that allows us to essentially write the domain as a continuous set of values between -3 and 3, and including -3 and 3 at the endpoints. So the range of this relation would be the set of the set of y in the real numbers such that y is greater than or equal to minus 3, but less than or equal to 3. Because our y values go between -3 and 3, and we have the points -3 and 3 at our endpoints. That's why we need greater than or equal to, because y can be equal to -3 and 3 as well. So next, let's look at two more examples. In example 3, I'm asked to find the domain and range of this relation, which is y is equal to 2x squared plus 1. So notice that here I've got an equation. So I'm representing this relation in terms of an equation. So my rule for associating the elements in the domain with the elements in the range is just an equation. So if you recall from previous courses, this equation is a quadratic equation. It's actually a concave up parabola because the coefficient on the quadratic term is positive 2. We don't have a linear term here. Our linear term is just 0x plus 1. So this is a concave up parabola with vertex at 0, 1. So it looks something like this on the side. It looks something like this. And the vertex of the parabola is 0, 1. So if we think about the graph of this, well, the possible x values that we can, what are the possible x values that we can have in our domain that essentially allow us to get out a real value for y? Well, here, this the graph of this parabola, I should label this as x and y. The graph of this parabola kind of goes off toward infinity in the x direction and the same thing in the negative x direction. Another thing to notice is that if we plug in any value, any real value for x here, so any value for x that's a real number, we're going to get out a value for y in our range. So the domain is essentially just the set of real numbers. So we write this as the set of x, of all x in the real numbers. The set of all x in the real numbers. The range is going to be, well, x squared has to be either 0 or greater than 0. Okay, so that means that when I have 2 times 0 plus 1, that's essentially going to be my minimum value. So the minimum value for y is going to be 2 times 0 plus 1. So the range would be the set of all y in the real numbers such that y has to be greater than or equal to 1. And that's the domain and range of this relation. So next, let's go to example 4. And example 4 is a little bit trickier. In example 4, it might not be obvious what the domain and range are, but we know that we have to, if we plug in a value for x in our domain, or if there's a value in our domain such that we don't get a valid value for y, if we don't get a real value for y, then that's not part of our domain. So in this example, we have x plus 3 in the denominator. So basically, I can plug in any real value for x, and I'm going to get a value out for y. But let's think about what happens if x is -3. If x is -3, I have 2 over -3 plus 3. -3 plus 3 is 0, and I'll have 2 divided by 0. Now remember that division by 0 is undefined in math. So if I divide by 0, I'm not going to get a valid answer for y. So that means that -3 cannot be in the domain of this relation. So my domain is equal to the set of all x in the real numbers such that x cannot be equal to minus 3. Now let's think about the range, and I'll show you guys a trick for getting the range in this example. So for the range, I'm not too sure what values I can get for y. So one trick to figuring out the range for these types of equations where you've got a variable in the denominator is actually to rewrite x in terms of y. So we're going to essentially rearrange this equation and find x in terms of y, and then we're going to see if there's any restricted values on y, or if there's any values for y that don't give us a corresponding value for x. So let's do a little bit of algebra here. We'll write out our equation first. Y is equal to 2 over x plus 3. And if we multiply both sides of this equation by x plus 3, we get x plus 3 times y is equal to 2, because when I multiply 2 over x plus 3 times x plus 3, I'm essentially multiplying 2 times x plus 3 over x plus 3, which is just 1. So I've got x plus 3 times y is equal to 2. Now we can distribute y into these brackets here, so I get xy plus 3y is equal to 2. I can now solve for x in terms of y if I move my positive 3y term to the other side of the equation. And I get xy is equal to 2 minus 3y. To isolate for x, I'll just divide both sides by y. So I get 2 minus 3y divided by y. So now let's think about this. Well, I've got x written in terms of y now. Now let's think about if there's any values for y where there's no corresponding value for x, because that'll give me my my range. So if y is 0, I essentially have 2 minus 3 times 0 divided by 0. And remember that division by 0 again is undefined. So if my y value is 0, there's no corresponding value for x. I get an undefined corresponding value for x. So the range in this case is equal to the set of all y values in the real numbers such that y cannot be equal to 0. So that's my range for this relation. Lastly, let's look at example 5. So in example 5, I have y is equal to the square root of negative 2x plus 1. Now the domain isn't exactly obvious here because I know that underneath the square root of or underneath this radical, I have to have a number that is positive. If I take the square root of a negative number, I get a value that's not real. And although we can define that in terms of the imaginary numbers, we're only going to consider the real numbers right now. So we're going to restrict the domain of this relation so that I get a real value for y. So how do we do that? Well, we can say that if the number underneath this radical has to be positive, well, that means that negative 2x plus 1 has to be greater than or equal to 0. So we can solve this inequality. We can solve this inequality by subtracting 1 from both sides of this inequality, and I get negative 2x is greater than or equal to negative 1. I can divide both sides of this inequality by negative 2, and because I'm dividing both sides of an inequality by a negative number, I have to flip the inequality. So I get that x has to be less than or equal to 1/2, because negative 1 divided by negative 2 is 1/2. Since I've divided both sides of an inequality by a negative number, I have to flip the inequality. So this essentially gives me the domain. My domain is just the set of all x values in the real numbers such that x has to be less than or equal to 1/2. Lastly, I'll look at the range. So what is the range? Well, if all of the values that we're going to plug into this radical or into this this square root here have to be greater than 0, then my range has to be just greater than the square root of 0. So my range is going to be equal to the set of all y values in the real numbers such that y is greater than or equal to 0. And that's my range. So the range is just the set of all y values in the real numbers such that y is greater than or equal to 0. Because here I can really just plug in any value for x that is less than or equal to 1/2, and as x gets further and further into the negatives, this number here is going to get bigger. And as I take the square root of a bigger and bigger number, y just keeps getting larger and larger and larger. So essentially I can get all values for y that are greater than or equal to 0 for my range. So that concludes this lesson, and we'll see you in the next video.